gone through with the endocrine system, focusing on the thyroid gland and then the parathyroid gland briefly. This is an image that one of my students in anatomy took. I like this picture. It's the human thyroid gland, so it shows all these follicles or sacs filled with fluid. And the fluid in those little sacs is made up of iodine and hormones that are being formed. So remember the thyroid hormones? I briefly introduced them with metabolism. Do you guys remember? Thyroid hormones, they're T3 and T4. Maybe I just breezed over them. But thyroid hormones are very important for several things, several processes inside of your body. Can you think of something the thyroid hormones actually help regulate or do? I heard something.
Your metabolism?
Your metabolism, yes. Thyroid hormones help to set your basal metabolic rate. If you have too high of thyroid hormones, your metabolism's gonna go way faster than it should. If you have low T3 and T4 thyroid hormones, your metabolism or BMR is gonna be slower. Now, a lot of people wanna jump right to hormones, because hormones and the nervous system, together those two systems, control virtually every important physiological process in your body, in your mind, in your brain, and in your body. But a lot of times we want to jump to hormones being the cause for various things. Like I feel like many people do that. Oh, so you probably have imbalanced hormones, or you have too much or too little. That can be true, but many times it's not the only culprit, or it's not the only cause of whatever is going on. So usually there's hormone panels, there's tests that can be done. Are your thyroid hormones normal? Are they in the normal range? Okay, yes they are. So we have to figure out what else is going on. Okay, so it's usually there's a whole series of tests you have to do to figure out when there's a problem. But thyroid hormones are very, very important for metabolism, among other things. So the thyroid gland, you can actually palpate the thyroid gland. It's kind of right on both sides of your voice box. Kind of surrounds like a butterfly-shaped gland. It goes under the cricoid and thyroid cartilage. This is the voice box. It's a butterfly-shaped gland that has a little connecting sort of isthmus right there. So this is the whole shape of the thyroid. It has two lobes, and it's connected by that little isthmus. Isthmus is just a bridge, a little central kind of connector. So they've got hollow spaces, like I pointed out on that first slide, lined with simple epithelium. So these are lined with these little simple cells. The interior is filled with a fluid. It's called colloid, and this colloid is where there's iodine collecting there, and iodine is involved in the production of T3 and T4, so the thyroid hormones. Now, the names are kind of hairy, but they're triiodothyronine and thyroxine, and your book goes into these. They're full out name. I could spell them if you want. T3, triiodo. Oh my gosh, I realized that word's long. And then T4 is, we can keep this one simple, thyroxine. So these are the main sort of two types of thyroid hormones. For simplicity, and you guys in here, you could say the thyroid hormones, or T3, T4, and I'll know you know what you're talking about. So outside of the follicles, there's other cells. So the follicle cells are here, these cuboidal cells that are surrounding these sacs or these follicles where the T3 and T4 are getting formed. But all these other cells, like out here, they're called parafollicular cells, and they secrete a different hormone, and that hormone is calcitonin. What word do you recognize in that term? Calcium. So take a guess, what do you think this one does?
The calcium reserve restored.
It's involved in the calcium reserves, yes. So it affects blood levels of calcium, regulation of blood levels or plasma levels of calcium. So we're going to talk about both of those right now. So if we look at this real close, this is right from a textbook. Here's the colloid fluid that's gathering. These cells lining the follicles are helping to produce all of that. Parafollicular cells are out in these other spaces here. They're not lining the follicles. These guys are making what? Calcitonin. These ones here are making T3 and T4 right in that space. Okay, so those are kind of how the thyroid is parceled out according to which cells are making which hormones. Okay. Yes, there. What do the thyroid hormones do? Okay, so the thyroid hormones, I said yes, they affect metabolism, how fast cells do all those metabolic pathways that we talked about, glycolysis, Krebs cycle, electron transport. Many of you had those down, by the way. You missed some little key things, but you had those pathways sorted down. You understood what came in and kind of what came out. Most people did. They stimulate protein synthesis. So thyroid hormones stimulate the cells of your body to make proteins. Okay, let's make some proteins. Let's make stuff. Also in development in the embryo, in the fetus, and in early infancy, maturation of the nervous system, so normal development of the brain and the spinal cord and the nerves, is aided by thyroid hormones, having the right levels of T3 and T4, thyroid hormones. Also, as we've already said, it increased rates of cellular respiration, and you might have maybe before this class not really known what that was, but now you know what this is, right? Increases cellular respiration, taking in oxygen, and your cells doing glycolysis, Krebs, electron transport, making lots of ATP. So using the oxygen as electron acceptor, making a lot of ATP, burning down fuels like glucose and fatty acids and proteins. Basically, this leads to effects on BMR, or basal metabolic rate. Okay? And so that's a big one, and that's one we typically think of with the thyroid hormones. So they elevate BMR, okay? So if your thyroid hormones are at normal to high levels, that will have a positive effect on your basal metabolic rate because of this, right? At the cellular level, you're speeding up metabolic pathways, so ultimately it leads to that. Okay, so calcitonin is the one that comes from the parafollicular cells, the other cells making up the bulk of the thyroid gland. What calcitonin does is it stops the resorption of calcium from bone, okay? So it stops the resorption of calcium from bone and stimulates the excretion of calcium by the kidneys. Your kidneys filter all the fluid of your body every minute of every day. So it does your total blood volume multiple times a day. And filters out all the fluid, regulates your blood pressure, your salts, your ions, and the materials that are in your blood. So the kidneys will actually start dumping out more calcium, and your bones will not be releasing calcium into the blood. Calcitonin is saying, no, we have too much calcium. We want to eliminate some of that calcium. Now, a lot of women will not have this problem, but this is what happens if there's sort of too much. So thyroid gland, the parafollicular cells are releasing calcitonin, and this actually calcitonin allows the bones to actually grab onto calcium mineral and build the bone tissue. So you have more calcium in the bones themselves. You're not releasing the calcium from bones into blood. So bone deposition means you're building bone, right? So bone deposition is you're building bone. Bone resorption means your cells are breaking down bone to free up calcium for the blood. So in this case, calcitonin is actually allowing the cells of the bone to build and add more calcium to them, to keep them dense, right? To keep the bone mineral density good. So this serves to decrease calcium blood levels. Increasing calcium in bone, increasing the amount of calcium you pee, keeping calcium in bone. So when you actually look at the blood plasma, calcium levels go down in response to calcitonin, okay? So calcitonin, and there's another hormone, it's called parathyroid hormone, or PTH. The endocrine system I really suggest doing flashcards for. That's what really helped me, because there's so many that are released by the hypothalamus, the boss, and then there's so many released by the anterior and posterior pituitary, and then there's a set released by all the endocrine glands and what they do. And they all control really important processes that are going on in your body. And when you get too high or too low, you end up with disease. So they're really important, but keeping track of all those is a little hard. So for me, I like flashcards, a little visual, and then a word on one side, what the hormone is. That'll help you learn them better. Parathyroid hormone, or PTH, it's actually secreted from the parathyroid glands, which it's hard to see on this diagram. There are better diagrams we have. Are little pea-sized glands, there's 4 of them, on the back of the thyroid. So if I were to take the thyroid out, pull it around and look at the posterior surface, you would see pea-sized 4 little tiny glands on the back of the thyroid, and those are called the parathyroids. They are specialized to make PTH. So they make parathyroid hormone. And then actually parathyroid hormone basically tells the bone tissue, the bone cells, to start breaking up the bone and releasing calcium into the blood. Parathyroid hormone is saying, hey, we don't have enough calcium in the other tissues and in the blood, so we need to start tapping into the calcium mineral reserves that are in the bone itself, okay? So this serves to raise blood calcium levels. Okay, so calcitonin ultimately decreases calcium levels. Parathyroid increases calcium levels. Okay, so they do exactly the opposite. And there's a lot of hormones like this. Hormones like this where one does this and the other does this. We have a word for that in endocrinology, and that's antagonistic hormones. Okay? If you are an antagonistic person, what does that mean about you? Do you go with the flow? Do you go with people? Do you help people? No, you go exactly. You oppose people. That sometimes it's a good cause. I oppose people sometimes if it's a good cause. I'm very antagonistic. I will fight hard for what I believe in, but that just in general, antagonism means you're going against, right? So these two hormones, while they're both good and healthy and needed, they are antagonistic in nature because one does one thing and the other does the opposite. Yes? Can you think of another set of hormones that we've already talked about if you've watched the video capture, the lecture capture, another set of antagonistic hormones?
Oxytocin and ADH, I think?
They're not antagonistic because they're working on two different systems. They're doing two different things. Yes, Tatiana.
Insulin and the other G hormone.
Give me the other G one. Glucagon. Good job. Yes. Okay. Insulin and glucagon. So tell me, insulin, what does insulin do?
Lowers blood sugar.
Lowers blood glucose levels. So what does glucagon do? Raises blood sugar levels. And they do a whole series of other stuff to fat cells and production of sugar or use of sugar, but they do exactly the opposite. This is how you can fast all day and actually be able to survive and have your blood sugar levels at a relatively good constant range without plummeting too far. Because glucagon goes, oh, we're not getting food. Okay, let's start putting some sugar out in the blood to keep the sugar levels where they need to be. So these two are another example of antagonistic hormones, PTH and calcitonin. And I would just say they are involved in calcium homeostasis. Like insulin and glucagon are involved in sugar homeostasis or blood sugar regulation homeostasis. These two are involved in calcium in the blood. So calcitonin lowers blood calcium levels, okay? It allows bone to put more calcium into itself and not have calcium floating around in the blood. All right, let me get rid of this. So, can we have problems with thyroid hormones? Yes. And actually, I have individuals in my family that have thyroid deficiencies, and so they have to take medications, basically, to supplement their thyroid hormone levels. So, and that tends to, when you have lower thyroid hormones, it goes with a whole suite of things that happen. Or you have too much thyroid hormones, it goes with a whole other set. If you have something in the diet, if you have a nutritional deficiency, like iodine deficiency, this is an element. Remember we talked about the essential minerals? Remember we talked about some essential minerals? And things like calcium, iron, phosphorus, selenium, iodine, magnesium. Those are really important minerals that your body uses for bone, for tissue, for enzymes, for reactions. Iodine is one of those. You don't need a ton of it, you just need a little bit of it, okay? So if you have iodine deficiency in the diet, basically your brain and your pituitary, through the anterior pituitary, it releases thyroid stimulating hormone, or TSH. This is in the first part of the lecture capture of this. Thyroid stimulating hormone comes from the pituitary, and it tells the thyroid gland, okay, make T3 and T4. Make the thyroid hormones. Make them. Go. Make them and secrete them. Because you don't have iodine to make them, you actually don't have any negative feedback coming from the thyroid hormones in the thyroid gland, telling the anterior pituitary and telling the brain, nope, we got enough, shut down. Because you don't have the negative feedback, because there's no thyroid hormones, the thyroid tissue itself starts to hypertrophy and grow out of control. So in science, when we say hypertrophy, this is a medical term, really. What does hypertrophy mean? I'll give you the two opposite words. They're kind of antagonistic words. And this will happen with a lot of endocrine glands and a lot of these conditions. oh, I can't, on the video, you can't see those words, but that's okay. Hypertrophy. This means to sort of enlarge in size, okay? It enlarges, enlarge. Organ or tissue or structure. Atrophy is the opposite of that, okay? And it means to shrink in size. So underdeveloped, falling apart, getting real small, shrinking. Enlarging, sometimes this happens due to, a tissue trying to compensate for not making the hormone and not being able to do what it's supposed to do. The heart in cardiovascular diseases, believe it or not, in congestive heart failure, the heart will get really, really big and hypertrophy, trying to keep up with the demands of the body and because it's not efficient. And that's one aspect of a type of cardiovascular disease. The thyroid will actually do that same thing. It will hypertrophy and get really, really big, trying to make T3 and T4. It doesn't have the negative feedback coming from up to the brain, and so it's just telling the thyroid, go, 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 make it, make it. It can't. It doesn't have iodine, you can't make T3 and T4, so it leads to a goiter. So usually we call that an endemic goiter. I'll show you what that looks like. It also leads to hypothyroidism. Hypo means under or less, right? So not enough thyroid hormones, hypothyroidism. This results in low metabolic weights, weight gain, sometimes lethargy, being very tired, fatigue, poor adaptation to cold stress. So when you get cold, you get really cold. It's hard to get warm, okay? Remember parts of metabolism, the three major parts: basal metabolic rate, thermogenesis, and eating, right? Specific dynamic function of eating. When you eat, you actually burn calories. And when you warm and you shiver, you're burning calories. You're using energy to do all that. And then physical activity, those are the three components. So with this, with not enough thyroid hormones, you can't, the thermogenesis component is compromised. You can't get warm enough, okay? And then something called myxedema. This is accumulation of fluids in certain subcutaneous or under the skin, back of the eye, certain areas of the body. Okay, there's another third component. This is cretinism. Cretinism is a very severe result of being hypothyroid, having hypothyroidism during a woman's pregnancy or up to the 6 months around of infancy. So a little tiny baby, and during pregnancy, when it was in utero, if the mother did not have sufficient dietary iodine, this can lead to something very severe called cretinism. It happens in certain countries. It's not as common here, but mainly where there's mineral and nutrient deficiencies that are very severe. And then we have the opposite of these. So this is not enough iodine, so you get a goiter. Not enough thyroid hormones, affects metabolism, affects the body, overall state. Not enough thyroid hormone in utero and in a little tiny baby. Now this is too much thyroid hormones in like an adult, and that's where we see Graves' disease. It's called hyperthyroidism. So this is too much activity of the thyroid or too many thyroid hormone, too much of it circulating. So if we focus at Graves' disease for a second, this is the most common type of hyperthyroidism. There are several different types, but we're going to go over this one because it's the most common. The person's immune system makes abnormal antibodies, and what this triggers is the oversecretion of TH, thyroid hormone, by those thyroid follicle cells. Lining the follicles, they're just pumping out way too much thyroid hormone, okay? Because the immune system has these sort of abnormal antibodies that triggers the thyroid to go a little bit crazy and to make too much. It's kind of an oversecretion of thyroid hormone. This is too much thyroid hormone, so if thyroid hormone is involved in protein synthesis and increasing BMR and thermogenesis and all these things, and you have too much of it, it leads to nervousness, okay, so overactive, sort of anxious, very nervous, weight loss, usually rapid weight loss, sweating, so profusely sweating, thermoregulating, hot, always very warm. I have that a lot, but that's just due to me. I'm always sweating, okay? Rapid heart rate, so the heart rate is sped up. Protrusion of the eyeballs is a feature that when this starts to happen, it's called exophthalmism. Ophthalmic refers to the eyeball. Exo refers to coming out of its socket. The eyeballs start to protrude sort of out of the orbits of the eye because it's this process of too much fluid, too much pressure that's in that cavity. So too much thyroid action, your metabolism is too high, and you have all of these things that go along with it, okay? And that's what we refer to as Graves' disease. I have an image here. There's a few in your text as well, the book that I gave you. You can see the exophthalmism, right? The eyes almost look like you're opening your eyes really wide, and they're kind of bugging out almost. I have a really close family friend, and she had Graves' disease. It became very obvious. She was just losing weight, and her limbs getting really thin, and just very fidgety and nervous. And then her eyes started kind of protruding, and I could tell right away. Like, I knew right away. It's very distinct. They have surgeries where they try to reverse this, and they do palpebrae stitching, where they basically stitch the inner and outer parts of the lids to kind of pull the eyeballs back in a little bit. But it looks constrained. It doesn't really treat the actual problem that's happening. You have to get rid of too much thyroid hormone that's being made. Yes?
You catch it early, is there like any way to like?
Yes. So usually if people catch it early, you can kind of reverse, you can take medicine and you can reverse sort of the progression of Graves' disease. The same thing with hypothyroidism or Graves goiter, iodine deficiency. If you can reverse those things, the thyroid can adapt back and you can get into the normal sort of balanced levels of thyroid hormone. But sometimes when it's really late like this and now the person is having signs of exophthalmism, surgically is really the only way. They try to stitch and do it surgically. And over time, sometimes it subsides a little bit, and but it's still obvious. It's still there. Because my close family friend, she had this exactly. Yes, yeah.
So if a mother has cretinism, does that mean that like her child will have Graves' disease? Like, is that what you're saying?
No. They're two separate things. So cretinism is only seen in little children.
Okay.
The cretinism results from a mom not having enough iodine and the fetus not getting enough iodine for their thyroid gland. So during production and when they're newly born, their thyroid gland is not able to make thyroid hormones. And during development, if they didn't have enough iodine and the mom and the baby weren't making enough thyroid hormones, development of the nervous system gets messed up. So the nervous system actually developing can be affected. You need normal thyroid hormones for not just metabolism, but for normal maturation of the nervous system. So, and here's another shot. I think this is from your book. So normally, so here's the cornea, that's the iris. The cornea is the white part of the eyeball. How you see with light goes through the iris and it goes right back to the retina. You okay back there? Mm-hmm. I'm sorry, I know this is dramatic. But okay, so light goes right back through the iris here. Normally, with your palpebrae, your eyelids, you don't see the top and the bottom part of the cornea, unless I'm really excited. Like if I'm really excited, then you see the corneas. But in general, you only see iris. So in an individual, before it's very sort of dramatic in symptoms, if you start to see cornea on top and bottom, that's a little bit of an indicator. They're coming out of the eyeballs and the eyelids more than they typically are. Okay, so now some of these are a little dramatic. There are some different Asian and South American countries too where goiters are much more common. It comes down to diet, nutrients, not getting enough iodine. So lack of iodine in the diet, you get like an endemic goiter. In this case, this is a massive example where it just was proliferating out of control. What would we say this is? Like in medical terms, we would say, what's happening to that tissue? It's hypertrophy. That is a hypertrophied gland. If a gland hypertrophy, something's wrong. Something is wrong. It's trying too hard to do what it needs to do, and it hypertrophies and enlarges in size. Cretinism, the one you just asked about, Melissa. Hypothyroidism in children. So this is usually in little infants, in babies, and toddlers. They usually have growth and mental defects. They have features, characteristics. They're short, disproportionate bodies, so they're shorter in size. They have a thick tongue. And a lot of times they have cognitive developmental defects. And sometimes they have a very much shorter lifespan as well. This is just from not having enough thyroid hormone in utero when their nervous system was developing. And then in their early part of their life, in infancy and childhood. And I think this individual, I think they're about 8. I couldn't remember, but I think they're about 8 years old. So how iodine deficiency causes a goiter. I mentioned that the reason it hypertrophies is because you don't have the negative feedback coming from the thyroid hormones and telling the pituitary and telling the brain, shut off that whole cascade. The hypothalamus makes TRH. And if you, I know these, I briefly went over these in the lecture capture. That's thyroid. Take a guess, RH. Remember, the hypothalamus either causes pituitary to release or not release or inhibit the release of different hormones. It's called thyroid releasing hormone. Okay? Okay? So this is one that comes from the hypothalamus. This is the boss. Okay? TRH, that causes the anterior pit to release TSH. Take a guess, what do you think TSH is?
Thyroid something hormone.
Not thyroid something hormone, that's funny though. Thyroid stimulating hormone, good. Okay, there we go. Thyroid stimulating, okay, hormone. That causes the thyroid to start dumping out T3 and T4, okay? If iodine in the diet is adequate, this trace mineral that we need. We can make T3, T4, right? We can do it as normal. If not, we can't make it, we have low levels of T3 and T4, so now we don't have negative feedback. So normally T3 and T4 at sufficient levels will circulate in your blood and in your capillaries, and they'll reach your brain and they'll reach your pituitary. This negative, whenever you see a negative like that, it means it's inhibiting, it's stopping that process. It's saying, nope, don't do that. Shut off, don't send any more TRH out, shut this off. Don't respond to the TRH if it comes, and don't release TSH. If I shut this whole process down, right, I don't make that. I lower those levels. So this is good. This is how your endocrine system has checks and balances, through negative feedback. I have enough estrogen, comes up, it shuts off the pathway that started it. Turns off the faucet. I got enough, right? And then all those kind of settle down, and then it gets produced again. So you have these cycles where they come in sort of nice balance, and then if you have too much, they get shut off. If you don't have those, they can't negatively feed back, right? If they can't negatively feed back, because there's no negative feedback, you're getting a constant faucet, go, 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 okay? TRH, TSH, stimulate, causes this gland, it doesn't look like it's enlarged here, but causes this gland to severely hypertrophy in size and bulge up, makes those cells grow and get larger, and trying to get them to make T3 and T4, okay? Low negative feedback, excess TSH, boom, it tells the thyroid just go, so it causes hypertrophy tissue to happen. And that's when it starts coming out of the neck, like in that more dramatic picture that I showed. It doesn't have to be that large. Sometimes it's just a little bit swollen, okay? All right. So the two different effects of hypo versus hyperthyroidism. You've got hypothyroidism and hyper in the right-hand column. Growth and development, if you don't have enough thyroid, you get impaired growth, okay? And like I showed the cretinism example, little kids, right? If you have too much, accelerated growth. Activity and sleep. Don't have enough thyroid, you're lethargic, increased sleep, very tired. Hyperthyroidism, increased activity, decreased sleep. They have insomnia issues, nervousness, weight loss, all the hyper sort of state that goes along with that. Temperature tolerance, intolerance to cold, very hard to get warm. These individuals with hyperthyroidism are intolerant to heat, they're very sweating all the time. And this goes on for all these sort of comparisons. I will say plasma levels of T4, so the thyroid hormone, is decreased, of course, with hypothyroidism, and increased in hyperthyroidism. Psychological aspects, a lot of times there's depression and apathy or lack of care with a low amount of thyroid hormones. And in hyperthyroidism, more of like a nervous, emotional kind of fight or flight state, unless I'm kind of high alert all the time. So very, very opposite effects. And notice, this is just from having a little bit too high of thyroid hormones or a little bit too low of thyroid hormones. This can affect your entire physiology for the most part. And I can go through every single gland and do that pretty much. So your levels of hormones have to be in homeostasis or in balance. When they get out, that indicates pathology or disease, right? Something is not right. Yes, the adrenals. These are the stress glands. This gets into the effects of stress on the body and your survival sort of fight or flight responses of your body. Jackie, did you have a question about thyroid?
But now you're talking about stress, and I'm like, don't stress.
Okay, ask me afterwards if you want to talk about it afterwards.
Yeah.
Okay, so adrenal gland, and can someone give me a warning at like 40, 35 or 40, so we can I can pass back the exams and we can go over them.
Yeah.
Okay, it's 22 right now? 22?
Yeah.
Okay, so we got time. Adrenal glands. Adrenal glands, this is an image one of my students took. Nice little cells all packed in these little columns. I have models of these, and I'll bring these models on Monday, and I have them in lab. I had them set up to show you in lab. I have the pancreas and the adrenal glands and the whole GI tract of the body with all the endocrine organs, so you can see them all in context in the body. So I'll show you on Monday. But you know where the kidneys are. The kidneys are sort of in the back, right, tucked under your false ribs, kind of lower back. On top of your kidneys is this little pyramid-shaped gland. So you have two adrenal glands, and they sit atop both of your kidneys. We have the adrenal cortex, the outer part, and then we have the adrenal medulla, the inner part, okay? So it's broken up into these two different sort of areas, okay? Adrenal cortex is this outer part, and then medulla is this deeper yellow part. So whenever you see, that's cortex, that's medulla. Medulla means like the inner aspect, or the middle part, middle medulla. Cortex is the outer part of the gland. The reason I emphasize that is because different sets of hormones come from these two different aspects or parts of this gland, okay? And they have various roles in the body, so they're different. They add to some similar processes, but they have separate roles. So the hormones from the adrenal cortex, so focusing on this outer part right here, all of those specialized cells that kind of line up into these columns like this, like I showed you on this first page. This is from the real human adrenal cortex. Those hormones that come from the cortex are made from cholesterol. Okay, so remember, and this was on the exam, right? Cholesterol gives rise to like the sex steroids, like estrogen, testosterone. It's a lipid, right? It's a ringed lipid. Cholesterol also is involved in making the corticosteroids, or the corticoids. These corticosteroids, corticoids, cortisol is sort of in the name. Cort is in the name. And they come from the adrenal cortex. That's where the name comes from, right? So the adrenal cortex makes the corticoids. So the three categories are mineralocorticoids, okay? And they regulate minerals in your body fluids. So the control, or the balance of sodium and potassium in your blood fluids is regulated by mineralocorticoids. An example is aldosterone. And there's a little video that I showed in the lecture capture, and it uses aldosterone as the example to regulate the kidneys' salt and water balance. Glucocorticoids, that name, where is that? Where have you seen that before? Sugar. So this is the regulation of sugar metabolism. So insulin and glucagon are the two main players, but we've got some other key players that do stuff when it comes to sugar regulation, and that is cortisol. That